Hi there. In this video, we're going to learn about the distributive property. First thing you need to know what equivalent expressions are. Expressions are equivalent when they have the same value. So for example, we have 2x plus 5 is equal to 5 plus 2x. These two are expressions and they are equal in value. Now we're going to talk about what the distributive property actually is. So to multiply a sum or difference by a number, multiply each term inside the parentheses by the number outside of the parentheses. For example, here we have 5 times 6 plus 7. You can just do 5 times 6 plus 5 times 7. So this expression and this expression are equivalent. Same thing here. You could do 8 times negative 3, which is a minus 3. And then you could do 8 times 9. 8 times 9. These two expressions are equivalent as well. So use the distributive property to write each expression as an equivalent numeric expression. Then evaluate the expression. So we have 5 times 11 plus 4. So first thing I'm going to do is I'm going to multiply that 5 across. 5 times 11, 5 times 4. Okay? And then what I'm going to do is I'm going to actually solve. 5 times 11 is 55. 5 times 4 equals 20. And then you're going to figure out the total, which gets you to 75. Positives and negatives. Let's talk about these a little bit. When looking at expressions, recognize what is in front of the number as the sign of the number. So here you would think of this as 2 times 10 minus 3. When using the distributive property, I want you to think of this minus 3 as a negative 3. Okay? Because if you think about it, 2 times 10 plus negative 3 will get you the same answer. I just always want you to get into that habit because while you can just do 2 times 10 equals 20, 2 times 3 equals 6, and then subtract the two numbers, while you can do that, it's going to get complicated later on when we throw in variables. So now at this stage, I want you to think of this as being a negative sign when you're using the distributive property. So here we're going to go 2 times 10 and 2 times negative 3. Okay? So 2 times 10 and 2 times negative 3. And then we're going to find the total of those two. 2 times 10 is 20. 2 times negative 3 is negative 6. So 20 plus negative 6 equals 14. Again, you would also get the same answer if you just did 2 times 10 is 20. 2 times 3 is 6. 20 minus 6 equals 14. You will also get the same answer. But I'm letting you know that later on in the next chapter, when we start throwing in variables, it's going to get complicated to think like that. So I'd rather you start thinking of this as a negative 3 instead of just a minus 3. All right, here's our next example. We have 10 minus 3 times 8. First, we're going to do is 8 times 10. Or sorry, we're going to go this way. 8 times negative 3 and 8 times 10. And then you're going to find the total. So 8 times negative 3 is negative 24. 8 times 10 is 80. And then you're just going to add the two numbers and get 56. Here's our next example. We have 1/2 times 6 minus 2. So what I'm going to do is I'm going to do 1/2 times 6 and get 3, right? 1/2 times negative 2. 1/2 times 6 plus 1/2 times negative 2. And then you're going to find the total. That's why there's this plus sign. So whenever you go from here to here, you multiply 1/2 times 6. Then you're going to add the product of 1/2 times negative 2. 1/2 times 6 plus 1/2 times negative 2. 1/2 times 6 is 3. 1/2 times negative 2 is negative 1. And then 3 plus negative 1 ends up getting you 2. All right. Using the distributive property is helpful, like in everyday math, because it helps you find products mentally. So if you had this problem 7 times 34 and you didn't have a calculator or you didn't want to take out your phone and look in that calculator, you could just do 20 times 30 plus 4. And then you could do the distributive property. Or sorry, 20. I don't know why I said 20. 7 times 30 plus 4. And then you could do the distributive property. So 7 times 30 plus 7 times 4. 7 times 30 gets you 210. 7 times 4 gets you 28. And then your total ends up being 238. See, I don't need a calculator to do that now. If I thought of this as 30 plus 4 rather than 34. All right, and here we have a word problem. So, a spaghetti dinner at the Italian Village restaurant costs $10.25. Use the distributive property in mental math to find the total cost of dinner for Sharita, her brother, and her parents. So if we look at Sharita, her brother, and her parents, we have 2 here, 3, and 4. So we have a total of 4 people. If each dinner costs $10.25, then you need to do 4 times $10.25. Now, who really wants to whip out their phone and use a calculator at the dinner table? Not me, and I don't know about you, but I was raised in my house to, not have my phone out at all during the dinner table. So, we're just going to use distributive property. So this 1025 here can actually be broken down to 4 times 10 plus 0.25. And now I can go across. 4 times 10 is 40. 4 times 0.25, well, I'm going to think of that as 4 times a fourth, right? So 1/4 of 4 is just 1. So 4 times 10 is 40, plus 1 gets me $41. So just like that, very quickly, I figured out that my total for this would be $41 without using a calculator. All right, and here are some concluding thoughts. You want to always assume that whatever sign is in front of the number is attached to the number. So in other words, here, 10 times 4 minus 3, I want you to think of it as 10 times 4 plus 10 times negative 3. Think of this minus as a negative when you're using distributive property. It'll make your lives easier later on. Distributive property can help you write an equivalent expression and make multiplication problems easier to solve mentally. All right, I hope you learned how to use a distributive property.